11IB, we are getting into 2D, which is composite functions. And if you just consider for a moment, the beginning of the word composite, your prefix, comes from the word compose. So when you think of composing something, a musical composition, anything where you're bringing several pieces together, it's always more than one that you're now putting together and layering within each other. So if you're considering two functions, one function is f of x equals x to the fourth. The other function is g of x equals 2x plus 3. We have two separate functions and we want to compose them together. So one way that you can think of this is kind of like a machine. If you begin with your input, which is x, and it goes into the g function machine first, you're going to get some expression, which we're going to call 2x plus 3. Now this becomes your domain, and we're going to put it inside of the second function, which is called the f function machine. And now I need to take this 2x plus 3 and raise it to the power of 4, because that is what the original f function was stated as. It was x to the fourth, or the domain raised to the fourth power. So then you get this expression out that looks like 2x plus 3 raised to the fourth power. So you have now just rewritten your function, putting the g function inside of the f function. When you do this, you're actually finding something. If you put g inside of f, what you're really doing is you're taking the f function and putting g of x inside of it, also known as f composed with g. So if you say it, it kind of looks like the word fog, and that's what this was saying up at the beginning. When you see fog, f of g, it's really like saying f of g of x. So that g of x is being put inside of the domain of f. The order is extremely important. So if you notice down here, again, this is just the beginning of your section in your textbook. We'll start just by looking through this example. If you put g, so f of x, or f of g of x, is basically putting g inside of f. So I take the function 2x plus 3, and I put it inside of the x for the f. So now I have 2x plus 3 raised to the fourth power. So that 2x plus 3 just replaces your original x. It becomes the new domain. However, if you did this in the opposite order, so g of f, or goth, however you want to say it, you're taking f and you're putting it inside of g. So that means I'm taking x to the fourth and I'm putting it inside of 2 times the domain plus 3, because that's what we were originally told. So that simplifies down to 2x to the fourth plus 3. These are not the same, so please make sure those do not equal each other. Please make sure that you're looking very carefully at the order that you are supposed to compose two functions together. Is it f of g or g of f? All right, so they are not equal to each other. Make sure you take a look at the order, as it is very, very important. So beginning our first example, we are going to compose g with f. And this, another way of saying this is just thinking of this as f of g of x. So we're going to put g of x inside of f. So the way this works is I'm going to take f, which is 3 times x squared, but I'm going to take g, and I'm going to put that inside, replacing the original domain of x. So that now becomes 2x plus 1 quantity squared. So if I were going to simplify this, I'd have to expand the 2x plus 1. So I would wind up with 4x squared plus 4x plus 1. And then I can expand by distributing my 3. So I get 12x squared plus 12x plus 3. And that is now my composition of f of g of x, or f composed with g, and then x is my input. So again, this is just my name of my new function. It has nothing to do, we're not multiplying f of g times x, it's just the name. It's my function composed with x, and I put the g inside of f. For our next example, you might be given a value to substitute in instead of just an x. So instead of getting an expression, you would wind up getting an actual number. So think of this as f of g of 2. So that means 2 goes into g, and then that value goes into f. So the first method that we can do is to take our f, which is 3, and basically I'm just going to write this out, f of g of 2. And I'm going to take f, which is 3 times x to the second power, but in place of that x, I'm going to put g, which is 2 times x plus 1. But in place of that x, I'm going to put the 2. All right, so what we just did was we outlined our problem using the f. We inserted the g, and then we inserted the 2 in place of the x. So you're just layering the problem so that you can then simplify. So always work from the inside out. I have 2 times 2, which is 4, plus 1 is 5, squared gives me 25, and then times 3, I wind up with an answer of 75. If we don't want to put all the layers in one step, one option is to start by just saying, well, what's g of 2? So if I know that g of 2 is 2 times 2 plus 1, I can find g of 2 to be 5. Then I can take f of 5, and I can replace the 5, so I have 3 times 5 squared, and then I can get to 75 that way as my final answer. So it just depends if you want to do everything in one step, like method 1, where you can show all 3 layers in one step, or method 2, where you first start with the inside and then work your way outside. And last but not least, notice that the 2 is now in a different place. In the last example, your 2 was in place of the x. However, now the 2 is in place of your y value, or your output. So notice the difference in where that 2 is located. So I'm still going to start with f of g of x. So f of g would be 3 times g squared, which is 2x plus 1. And now I'm going to set that equal to 2. Notice the setup for this one is a little different, and I need to make sure that I recognize my job now is going to be to solve for that x value. So if I need to solve for x, I'm going to have to either expand and then take the square root, or I can write this as a quadratic. So if I did expand this, we did this a few slides ago, you wind up with 4x squared plus 4x plus 1 equals 2, and now you have 12x squared plus 12x plus 3 equals 2. All right, so again, every time you solve a quadratic, you want to have your quadratic equal to 0. So I'm going to go one step further, subtract the 2. So now I have 12x squared plus 12x plus 1. So this should look very familiar. We have a quadratic set equal to 0. You guys have tons of options on how to do this. This one will not factor, so your choices are, do I use the quadratic formula, which we know how to do, so I'm just going to put a star by that one. That's a familiar one to us. Should I graph it and then look for the x-intercepts? Again, that one should feel pretty familiar to us. And then there's one other option that we haven't done yet, which is called the polynomial root finder. So I'm going to show you guys that right now. So go ahead and grab your calculator if you don't have it out next to you. Push pause, and then we'll look at that together. So again, turning on your calculator, we'll start a new calculate screen. And we'll enter, we're going to go to, menu and algebra. And you'll notice that there's a polynomial tools as your third option. And we're going to go down to where it says find the roots of a polynomial. It's going to ask you what degree your polynomial is. So I have a second degree because it's x squared. So the highest exponent is a 2. we do want to find, you can find real, or we could wind up looking at complex. So if we know that we might get an imaginary answer, so a non-real answer, I can push complex. So let's see what happens when I push real. And then it's going to ask you for your A, B, C values. However, it asks you for A sub 2, A sub 1, and A sub 0. So if I go back, I believe they were 12, 12, and 1. Yes, they were. So we'll come back here and we'll put in 12, 12, and 1. Okay? So it's going to say, I want to find the roots of this polynomial that I just entered, and then it says comma x, and that just means with respect to x as my input. And I push enter. And now I have my two solutions. So without graphing, I can also find my two solutions by using the polynomial root finder. All right, guys, so last but not least, this is your last challenge. Try this one on your own. Try g of f, so that means you'll be putting f inside of g. And also try f of g, where you put g inside of f, and see what you get for both of those. All right, push pause, try them, and then I'm going to uncover the answers in just a moment so you can check. Have a good night, guys. We'll see you next time.